Okay, so you know how we're always talking about AIs that can see the world? We call them vision language models, or VLMs. They're the magic that lets your tech understand pictures and words together. Well, hold on, because Apple just dropped a paper on a breakthrough that could completely change the game, especially for that phone in your pocket. They've cracked a problem that's been a major roadblock for years. Let's get into it.
And that really brings us to the single biggest question here. It's the one thing that's been holding back true on-device AI forever. See, you could have an AI that's super detailed and accurate, or you could have one that's crazy fast. But getting both at the same time? That's felt pretty much impossible. So what's the deal?
It really all boils down to what the researchers call the high-resolution dilemma. This is the fundamental trade-off that has put AI developers in a really tough spot. Do you want your AI to be smart, or do you want it to be fast? You had to pick one.
To really get why, just think about this example from the paper. An AI is trying to read a street sign. In a low-res image, forget it, it's just a pixelated blob. But you feed it that same image in high resolution, and boom, it can clearly read "Do not enter." So for anything that needs real detail, like reading a document or understanding what's on your screen, high-res is an absolute must.
And this, right here, just lays out the problem perfectly. The more pixels you give the AI, the more accurate it gets. But all those extra pixels mean way more data to crunch, which creates a ton of latency, lag. So you're stuck in this endless loop. Do you want a smart AI that's slow or a fast AI that's kind of dumb?
So if you're going to solve this, you have to find the logjam. You have to pinpoint exactly which part of the whole process is grinding everything to a halt. And check this out, because this is where it gets really interesting. When you use a low-res image, the AI's brain, the large language model, is doing most of the work. But look what happens when you pump up the resolution. That vision encoding time, the time it takes the AI's eyes to see the image, it just skyrockets. It completely takes over and becomes the massive bottleneck we're looking for.
And this is where Apple's new baby, FastVLM, enters the picture. The team realized that to fix the speed problem, they didn't need a bigger, faster brain. Nope, they needed a totally new, way more efficient set of eyes. They pulled this off using what's called a hybrid architecture. And the idea is it's so smart. Instead of picking just one type of AI model, you fuse two different kinds together. You get the best of both worlds. It's like having a sprinter for the short dash and a marathon runner for the long haul, both on the same team. So here's how that actually plays out. First, you have the sprinter, these really fast, simple convolutional layers. They do a quick scan of the whole image, just getting the lay of the land. Then, the marathon runner, these super powerful but efficient transformer blocks. They come in and zero in on just the most important details. The result? It ends up sending fewer pieces of information, or tokens, to the AI's brain, but they are way higher quality. It's the classic work smarter, not harder.
Now, of course, a cool idea is one thing, but you gotta see how it performs in the real world. So the researchers put their new hybrid eye up against the old guard, the traditional AI architectures, to see what would happen. And they made it a really fair fight. They took a standard VLM and kept everything the same, the brain, the training data, all of it. The only thing they swapped out was the vision encoder, the eyes. They took out a big standard one called ViT/14 and plugged in their new hybrid, FastViT. And honestly, the results were just wild. First off, their new model was 8 times smaller. I mean, just that alone is a huge win when you're trying to cram powerful AI onto a device like a phone. But the real jaw-dropper was the speed. It wasn't just a little faster. It was 20 times faster. Not 20%, 20 times. That's the kind of performance jump that completely redefines what's possible in real time.
But they weren't done. They kept refining the idea and created FastViTHD, a version specifically tuned for those high-resolution images we were talking about. Get this new version is up to 3 times faster again without losing any accuracy. It's just the best of everything they discovered.
So the hybrid approach was a huge success inside their own test. But the real question is, how does the whole FastVLM system do against other popular models that are already out there? All right, first up, they put it against a model of a similar size called Lava 1 Vision, and
it wasn't much of a competition. FastVLM was 85 times faster. It's not even in the same ballpark. It's playing a totally different sport.
Okay, what about another one? Next, they tested it against another well-known model, small VLM.
And again, no contest. FastVLM was over 5 times faster, and it was actually more accurate too. But here's the final boss. They put it up against a giant Cambrian 1, a much, much larger model. We're talking 7 billion parameters. Surely the bigger model has to have an advantage here, right? Wrong. Even against a competitor that was orders of magnitude bigger, FastVLM was 21 times faster. The numbers just speak for themselves. This thing is a monster. It's a total game changer for AI on your device. So, let's zoom out. What does all this technical stuff, latency, hybrid architectures, all of it, what does it actually mean for us? Well, it means we are right on the edge of having AI that can genuinely see, understand, and react to the world in real time. So what can you actually do with all this speed? Well, because FastVLM is so small and efficient, it all happens right on your device. That means way better privacy, your data stays with you. It means instant answers, which is huge for things like accessibility tools that can describe your surroundings in real time, or think about more responsive and immersive games. The demos even show it analyzing an iPhone screen to help a user navigate. This isn't just a theory, it's a huge practical leap. And all of this leaves us with one last massive question. For so long, we've been stuck with that annoying trade-off between an AI being fast and an AI being smart. Now that that barrier has basically been obliterated, you have to wonder, what's next? What kind of amazing new apps, tools, and experiences are we going to build when every device we own can see and understand the world as fast as we do?